Hello everyone, welcome back to my YouTube channel. In this video I'm going to discuss about constants, variables and functions which are very important for calculus. To begin with, constants are the quantities which doesn't change. In mathematics, we use certain alphabets to denote constants, that is A, B, C, D up to Q. Anywhere in the mathematics, in the calculus part, you come across A, B, C, D up to Q, we have to treat that as constants. Now variables are the quantities which changes, and we use only these alphabets to denote the variables, that is X, Y, Z, U, V, W, R, S, T. That's it, only 9. Now to have a good understanding about constants and variables, I'll take one simple example. I've taken one quadratic equation. Now if we define this quadratic equation, how we define? We say it's of the form ax square plus bx plus c, where a, b, c are constants. You can compare what are a, b, c here. It is 2, 5, 3, which are constants. And x is a variable. Why we say x is a variable? This quadratic equation has two roots. Let's assume alpha and beta. So x can take alpha, x can take value beta also. So x is a variable which is not constant. Now let's see what you mean by function. Now I'm going to explain the function which is enough to understand the concepts in the calculus part. It's very simple, an association or correspondence from one variable to another. Now let's take x and y, two variables, and if these x and y are connected through some means of f, you'll understand what do you mean by this f when I take some examples. So if x is a variable associated to y through some means f, we say y is a function of x and we denote that as y equal to f of x. Remember, x is the input and y is the output. So y depends on the values of x. So here we say y is the image of x, and also we say y is a function of x. I'll take one example here. So y equal to 2x plus 3. So we have variables x and y. They are associated to each other or related to each other. And here y is expressed completely in terms of x. Y value depends on the values of x. So y is a function of x. So that we denote this as y equal to f of x. Now here in this example, there are variables x and y. They are related to each other. And y is expressed completely in terms of x. So we say y is a function of x. And we denote that as y equal to g of x. You can also denote this as y equal to f of x, but y equal to 2x plus 3 is a different type of association, and y equal to x square plus 2x plus 1 is a different type of association. So just to show the difference here, we use a different alphabet here. Now in this, it's a different type of association. Y is expressed completely in terms of x. So y is a function of x. So here I've used h just to show a different type of association. If suppose the first function is in the first problem and second function in the second problem, we can always use the letter f itself. But if the first and second are in the same problem, if we want to show some difference, we have to represent by a different alphabet here. But always it means y is a function of x. Now I'll take another example. Here both x and y are associated or related, but here x is expressed completely in terms of y. That is, x is depending on the value of y. So here we say x is a function of y and we denote like this. In this example also x and y are related, and then x is expressed completely in terms of y. So here also we say x is a function of y, and using of f and g is as same as the concept which I explained in the previous examples. So in this example also x and y are related. X is expressed completely in terms of y. So we denote that as x equal to h of y. Now I'll take few more examples. Now we can see here we have variables u and v, they are related to each other like this. So u is expressed completely in terms of v. So we say u is a function of v. Next example, z and x are the variables which are associated, but z is expressed completely in terms of x. So here z is a function of x. And in this, y is expressed completely in terms of z, and they are related to each other or associated to each other. So y is a function of z. So I'll denote that as y is equal to f of z. So it's all different variables association. So I'm using the same alphabet letter f. Now I'll take one example, y equal to 2x plus 3. And you know y is a function of x here because y is expressed completely in terms of x. When I give x equal to 1, y equal to 2 into 1 plus 3, which is 2 plus 3, which is 5. And when x equal to 2, y is equal to 2 into 2 plus 3, 4 plus 3, which is 7. Now when I give value for x, y is taking a value. So in y equal to f of x, here x is called the independent variable and y is called dependent variable because y is depending on the value of x and x is not depending on anything. In the first example in this slide, u equal to f of v. So v is the independent variable, u is the dependent variable. In z equal to f of x is independent and z is dependent. In y equal to f of z is independent and y is dependent. Now let's discuss about how to separate constants and functions, which are very important for solving problems. In differentiation, we come across differentiation of constants are 0. And we come across differentiation of constant into function is constant into differentiation of function. So we must have a very good knowledge about constant and functions so that we can answer properly. Now it's very simple. Based on this note, you can differentiate between constants and functions. Constants doesn't have any variable in it. Let me take some examples. So log x is a function, log 5 is a constant. So for different values of x, so this log x gives different values. So that's why that's a function. And log 5 is just one value, 0.6990. So it is constant, it is fixed. So remember, if you find any variable, so that is a function. Otherwise, it is always treated as a constant. Let me take one more example. So x to the power of n has a variable x, so it is a function. Whereas a to the power of n or e to the power of n doesn't contain any variable. So these are constants. Now in 5 sin x, you can see 5 is a number which doesn't contain any variable, whereas sin x is a trigonometric ratio, trigonometric function which has a variable x. So 5 is a constant, sin x is a function. Now in this example, log x by log a. So here if we split 1 by log a doesn't contain any variable, so this is a constant, and log x is a function. In this example, sine of cos x contains a variable x, so this is a function. So sine of cos x is one function, like how we write sine theta. So 5 by 2 is a constant because it doesn't contain any variable. So this is the basic idea about constants and functions. So that's all guys in this video. So thank you for watching. Please subscribe to our channel and hit the bell notification icon.